Hello, 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 hello. Good morning. Hello, Hannibal. Hello, Nathan. Hello, Dragesh. Hello, James. Hope everyone is doing well today. Hello, Adolf. Hello, Alka. Hello, Danielle. Hello, Anthony. What would all of you like to talk about today? Hello, Sarfaraz. I mean, we finished up the PW mini project yesterday. I think I might, cross through that one. Hello, Abembio. Pandas. The bear or the Python package? Anything in particular about pandas? Uh, Safraz, please discuss some project ideas we're going to work on and showcase on GitHub or Resume. Um, well, so I think, as a kind of general idea of something you could do in terms of trying to show off your skills is, well, find some interesting set of data. By interesting, I might mean interesting to you. And work on some sort of project, which would show off your data manipulation, data aggregation, and data visualization skills. I mean, if you could take this data, this prescription data, and can you show some interesting visualizations with this data? Or extract something interesting from this data, right? This is kind of what, I mean, to some extent, the PW mini project is doing and the DW mini project is doing, right? Is you want to look at this data and extract interesting information from this data. And I continue to say, well, find some data set which is interesting to you. Maybe you have some sort of personal interest in this data for some reason or another, because, well, that could help keep you working on this sort of project. What we might do towards the end of the unit right here, because I know this is my first time teaching Unit 1. I've taught Unit 2 several times here in World Quant. My colleague who was doing Unit 1 before, like what he would often do towards the end of Unit 1 is to work on building some kind of small web application. Like we could talk about I mean, there's this notebooks about like, data munging. We could talk a bit about doing some web scraping, for example, or using an API to get some information from some website or some web endpoint. And well, could you build like a small web application using Flask, say, and deploy this web application online? Right? It's not a bad skill to learn something about. Could you write, as I said, right, can you write like a small web application which might maybe take a bit of input from a user, use this information to get, to extract something from, extract some information from a web endpoint, an API, and display something to a user. So it's those sorts of projects. Basically, find something that you are interested in doing and go out and try and do it. And, see what kind of success you could get. Like I said, I thought about that. Well, we could probably do something kind of similar towards the end of this unit, right? We could talk a little bit about Flask and how you use Flask. I would probably switch to using my own laptop to do some local development on a Flask app first, and then before I would deploy this online. So that's my general advice. Yeah, just find something that you're interested in doing, like find some data that interests you, and what can you do with that data? Try your newly discovered Panda skills. Yeah, so we could talk a bit about some matplotlib. So yes, that reminds me, Abdul Rauf, that's probably you that was asking about matplotlib here. So let's see here. Let's create some new notebook here. Let's see here. Well, let's do those two imports. So what's let's with gzip.open. Let's see here. Expected string f dot read. Right. Yeah, this might be easier to do after talking about pandas, because then we could load this information into a pandas data frame and do some grouping. Um, why opening as a JSON is better supported measure to take? Well, it's just that this will, essentially interpret this information. If I do f.read, well, we could see a bit of difference here. First of all, if I load this information, well, it says here, well, my kernel dies, so that's one reason. The reading this right here is essentially like reading in as a big string, right? Reading information from a file right here. So I want to read. Oops. Reading this information right here, this is coming through as a big string. And it kills my kernel trying to print out this big string. I could load this in, as a pandas data frame. I would need to load it in as a pandas data frame if I want to use .head. Is it load JSON? Right, I could read this is, a string. Well, I want to interpret this string as JSON, and pandas will actually turn the JSON into a pandas data frame. Right, so I couldn't use, once again, I could not use .head the way I was loading it before, because it was loading it in as a JSON file. Right, then it was being interpreted as a list of dictionaries. If I use pandas, I could read a JSON file, and pandas will read and interpret the JSON and create a data frame. From that JSON. So, yeah, if I'm looking at this information and it will fit into the memory of my computer, which this will, I will tend to go for pandas, right? Because pandas gives me lots of useful tools to examine this information. Right, pandas can do summary statistics for me. I could draw graphs, from inside a pandas data frame. I can do the kind of grouping that we, were talking about in the PW mini project using pandas. Right, the describe method, I can get some basic summary statistics out of the information in this data frame. All the numeric columns, right? I have this pandas data frame. So remember, what is this? This type of data is a pandas data frame. Using the describe method, well, the describe method will basically give me some summary statistics on all of the numeric columns. So the items is numeric, this NIC is numeric, this act cost is numeric, quantity is numeric. Describe will give me the summary statistics for all the numeric columns. Mean and standard deviation and min and max and these quantiles right here, which we had to write our own function to do in the PW Mini project. But pandas allows me to do lots of easy things. If I look at, items, of course I could get the mean through the describe method. Well, I could select a column and, well, get the mean just by applying a function to this information. Or I could select a selection of columns. Oops. Or I could select several columns and, well, apply the mean, and, well, I'll get a mean for each of those columns. So this is the kind of thing that pandas lets us do rather easily. The group by kinds of operations we were doing in the PW Mini project, we could do with, a line of code, for example, in pandas, right? Group by and say select this items column and compute a mean, and this will give me the mean of the group's data. So, so these are some of the kinds of things, well, we could do. So, for example, when I'm, you could also do plotting from inside of a pandas data frame, right? The plots tools. So what we could do, for example, plotting this information. So we could do PLT. Let's if I this kind of plot probably isn't particularly interesting. This is essentially just plotting the, as I said, the quantities of each of these items for all of my 382,000 rows. Right, this doesn't really tell me a whole lot of information, because there's no kind of linear relationship. The x-axis right here is literally the row number, and the y-axis right here is just the number of items. So this plot isn't, this plot isn't particularly interesting. All right. Well, and could ask a question which is not necessarily related. You're saying x plus equals 1. X equals plus 1. This is going to assign x to be the value 1. Right. This right here is literally just saying, well, I want to assign x to be the value plus 1. This right here, this plus equals, is an operator. Same as x equals x plus 1. So yeah, right, we would, to get some interesting plots, well, we'd probably want to aggregate our data here. Does pandas join the 2 or more data frames? Well, pandas can do joins. So, right, to do a join on 2 data frames, I don't think you could do more than 2 at a time. You basically want to do a join, and then you do like another join on the results. So, right, the idea here, remember, this was the data from the PW Mini project. Well, practices has like a code. The data here has a practice, right? That the practice column in this data frame matches the code column in this data frame. So we could do a join. I could do like data dot, the method name in pandas though is merge. And if I want to do a merge on practices, if these data frames shared a column name, I could use the keyword on right here. But the column names are different, so I have to tell I have to tell pandas, well, I want to look at this column in the so-called left data frame, the left data frame being data, the right data frame being practices. And then, it looks for matches. It says, well, find the N81013 and match the code for N81013. And so, we end up with a data frame as a result. Let me just do head right here again to get the first few rows. Right, so again, well, every row, the practice right here, should match the code. And it, essentially appends the information from one row and one data frame to one row in another data frame. So the merge method right here will merge two data frames. If you wanted to merge more than two, well, you're going to have to do it kind of as a series of merges. Right, so the merge method said, you could do how there's an inner join by default. Said if the column name is the same, you could just use the keyword on. You could join, but we have different column names. This is where we use left on and right on. If you wanted to, well, you might use an index on one of them or both. You can also have some condition on this merge data frame. Well, I mean, you could always apply whatever sorts of conditions you would like, to say select a subset of data or what have you. So, yeah, you could, you could either merge them and then apply some condition, or apply some condition, say, and then and then merge them. It might say, well, oh, excuse me. So, all right, getting a little jumbled here what we're doing. So, right, the point here, well, sorry, let's go back to some plotting, right? So I said this plot right here doesn't tell us anything particularly interesting, because the x-axis right here is literally just the row number of this data frame, and the y-axis is just the number of items. There's no relationship between these two, as you can see. Something more interesting, you might say, well, data.group by, say, our BNF name. Let's do a mean. Let's select items, do a mean, and then I might say, well, I want to plot this. This is essentially a bar plot of the mean values of the items grouped by BNF name, but they haven't displayed all of the labels, and well, you probably wouldn't want to because it's too busy. But each each bar, if you like, right here is, the mean of the number of items. Again, well, is this all this useful? Well, I can't actually pick out, which of these items is the largest one here at the moment from this plot, but this gives me, I guess, some kind of information. I guess matplotlib is more interesting, so let's import numpy as np. We could generate some data. Let's say x is np.a range. Y is 3 times x minus 4 plus np dot random size equals right, like maybe here's some, relationship, right? I've made some relationship between x and y, but I've added some random noise. Right, basic matplotlib plot. So plotting x versus y. I can add on some labels. Right, so a basic plot. If I'm doing matplotlib, which I'm doing right here, this is how I could add on some labels. A label for the vertical axis, the horizontal axis, the vertical axis. I could add on some title. Maybe I have some so here's a basic line plot. Right, plot right here will give me a line plot. So we basically plot the pairs of x and y and join them with lines. That's no good. To be honest, I'm not sure I understand your question. We could get histograms. Oh, you're saying can we get a trend line as in Excel? You're going to need to use other tools to do that kind of thing. Yeah, if you want to do linear regression, well, you're going to have to use other tools. You could either use scikit-learn and do linear regression, or you could do SciPy to do some linear regression, or stats models. But yeah, matplotlib doesn't. Matplotlib doesn't have the tools for finding a trend line for doing linear regression. You need other tools. Is there a pivot table like functionality in pandas? Yes. I have to remind myself what's the proper name. Yes. Yes. Let me see here. Let me remind myself. Let me see if I could remind myself of what the name is. Perhaps do some, example or some kind of simple. Let's see here. Yes, there are, pandas can do loads of things. Let's see here. Oops, that's not having an example I want. Yeah, this is sorry, a few questions here while I'm searching for some. Kind of the problem, of course, is we need some data on which to apply these things. So let me add some things here, and I could look them up and maybe find some interesting data. So pandas, we have things like pivot. Can you make pivot tables? Yes. We could say more about merging. So Tosin, well, the part of what you're talking about is a kind of a combination of pandas and matplotlib kinds of things, right? You have data for it hourly for 7 days. You want things like sums and averages, and you want to be able to plot charts. Yeah, well, you could do things like that with pandas. This is what pandas is all about. It's the data aggregation, manipulation, plotting kinds of tools. So yeah, this is what, like the pandas and like the data munging kinds of notebooks are talking about. What can we do with pandas? Well, we could do loads of things with pandas. There's, big books written on the functionality of pandas. So, yeah, we also, as was reminded here, right, there's a little bit of an introduction in the basic DS modules notebook on pandas. But this notebook right here, is, it's going to talk a lot about the kinds of things you could do in pandas. So, apologies, I'm just double checking the schedule when it is that you are getting these videos. There's some videos I know that went out this week about pandas. Well, my computer's running very slow this morning. So, this week's videos, the email you should have gotten, like this week's notebooks, are this DS Pandas notebook and this DS Intro Statistics notebook. Right, so, and this is what, like, the videos we're talking about. Say, part of the videos we're talking about this week is about pandas. There's a whole lot of functionality which is available in pandas. It's hard to describe exactly how much functionality is available in pandas. Because if you want to do something in pandas, there's probably a way you could do it. If there isn't a way that is provided for you, well, you could write your own functionality and apply functions to pandas, columns or rows, or aggregate things how you want. So, as I said, these videos this week, are talking about, part of the videos we're talking about this DS Pandas notebook. And we've probably, scratched the surface of the things you could do with pandas. You talk about, how can you create data frames. The basic kind of object in pandas is a data frame or a series. We can kind of think of a series as a single column. A data frame is a collection of columns. A data frame is effectively a dictionary of pandas series. The pandas data frame is effectively more or less like the answer to Excel's single spreadsheet. It says here the rows correspond with some observation. The column contains one type of data. So like a column is a homogeneous collection of data, the same data type. Like here in this example, well, we have a BNF code. These are all strings. BNF code is strings. Items are integers. Practice is a string. BNF is a string. NIC is a floating point number. How do I know this? Because a pandas data frame has an info method. And the info right here tells me something about the data frame, right? In particular, that BNF code, well, the data type is an object. More or less in a pandas data frame, object might typically stand for string or something more complicated than an int or a float. Right, but the items right here, these are all integer values. The NIC, these are all floating point values. Quantity, these are all integer values. This tells me for every column how many non-null entries I have in that column. Here I have a data frame. I have no non-null values, no missing values. Right, I'm told I have this many rows. This is a number of rows. This is the index right here, this bold number 0, 1, 2, 3, 4, etc. I have 382,726 rows, which are indexed with this integer from 0 to 382,725. So this tells me the data types of each column, how many non-null entries I have in each column. So the info method tells me some information, as the name suggests, about the data frame. As I mentioned before, the describe method, I guess I erased it. The describe method gives me some basic summary statistics on the numeric columns in my data frame. Right? One method, data.describe, I get all this information about the numeric values in my data frame. And this output right here is itself a pandas data frame. So, I could select a particular column. I could select the column about the items, and I get this information about that column. Or I could select, a pair of columns. And I get a data frame. As I said, the type of this output right here is itself a pandas data frame. And so I could manipulate it as such. And I could pull out specific, rows. I could pull out the mean of this data frame. So there's a lot to learn about pandas. As I said, the videos are only going to be kind of scratching the surface here. Hannibal, do you have to learn about the artist and backend layers? This is about matplotlib, I assume. I don't think you have to. I mean, it could help. Matplotlib can, there's a lot of functionality as well in Matplotlib. I'm always looking things up because I can never quite remember the syntax for Matplotlib. In real life situations, would it be embarrassing to stick to the tools I'm more conversant with, especially on the data cleaning part? I don't think so, but at some point you might be encountering data sets that are too large for Excel to handle. And then what do? Well, you know, pandas will, in principle, pandas will handle, any kind of size data set. It starts to slow down once the size of your data set does not fit into the memory of your computer. Yeah, as Hannibal says, you can't clean large data sets with Excel. But yeah, once again, Excel has its limits, which were kind of demonstrated somewhat dramatically and in a poor fashion by the NHS in Britain when they were using Excel to keep track of COVID cases, and well, they ran out of rows, and in some cases, they ran out of columns. You can clean 700,000 rows with Excel, but the limit of Excel is about 1,000,000 rows. So yeah, if your data set is large enough, you might need to use other tools to go about cleaning your data and doing your data analysis. And I guess, as I said, right, Pandas has lots of functionality. Well, if there's functionality that it doesn't have, we could write our own code, right? We could harness the power of Python and write our own more custom functionality to, say, clean our data and prepare our data for us. So, I mean, I definitely think it's worthwhile taking time to learn more about pandas and the functionality that is present in pandas. As I said, there's loads of functionality here that's available. If I Olaya says, I want to work with real life data and not one from Kaggle. How do I source these real data and what method will I use to extract them? Often what you might be using is some sort of web API to get the data. Like some data may be made available online in some fashion. And then, well, I might be using some tools to download this data to make requests. So in particular, say there's a request library. And with requests, this is what we often are using to get data from, say, websites. So just as a quick example, I know today's office hour has been a bit all over the place, for which I apologize. I'm not 100% on the ball this morning. So let's, I'm kind of stealing some example from elsewhere. So, um, so like a web URL. So let's do the following right here. So address details. Oops. So let's say I want to look up some information on an address. I could request.get headers. So, like, for example, there's a website, right, called OpenStreetMap, which I can make requests to, right? This is a website. If I were to copy and open a new web page and paste in this website, right? This is the website that I'm making requests to. And I could search, I could say search, well, I want to search on 1600 Pennsylvania Avenue, Washington, D.C. And this gives me back, you know, a map. I could get some data right here from the kind of raw JSON that I would get back from making a request. Well, I could do the same thing from inside a Python program. So the request library allows me to make requests. I need to, you know, give its information in a suitable format, right? I would need, say, to come here, you know, look up this information, right? Like, how do I use this API? Right? I might need to look at the documentation, right? API documentation can be found at this website, right? So I might go to this website. I'll look up this information and say, well, you know, how do I go about making a search? What kinds of parameters that I have to give? here I'm saying I want my format to be returned as JSON. I think this is saying I just want a single address. My query string that I want to search on is this string here, this address. I have to do a little bit of fiddling about right here to try and make OpenStreetMaps. I kind of fool it a bit. I'm not actually a robot, if you like. I'm not using such a library to make requests, even though I am. You can see I make my request, and what I get back is several things. One is a JSON object that I get in return. This gives me a latitude and longitude, for example, as strings. This gives me, an address right here. So yeah, right, you basically have to search for data that's available, in some format. It could be as a data set that you could download. Maybe there's, data available that you could hit by using some API like I did here. And you might be able to download this information directly, or again, you might use some, Python. You might write some Python code to download this information for you instead of having to go to a website yourself. But it's getting the data in some fashion, and then getting the data into a format that you could use to analyze it. There's no one, I can't say, well, you could always use this method or that method, right? It's going to depend upon where the data is located, what the format of the data is in, and so on. So finding the data is probably going to require, effort on your part. You have to do some searching. You have to find out where the data is located and how you could obtain that data. And then once you obtain the data, well, it's what format is the data in, and using appropriate tools to read and extract that information and get it into a format that you can use. So that's the kind of short answer. And I see that I'm out of time for today. So apologies for the somewhat disjointed office hour today. I will see you all tomorrow, but maybe, if you have a chance to read or listen to more of the videos, we could talk some more about pandas in general, and at some point, or maybe wait till next week to work on the DW mini project after you've had a chance to read all about pandas and watch the videos and try some things out. So I will see you all tomorrow.